A circuit consists of the power supply, the conductors, and the load. The load is typically controlled with one or more switching devices. Notice in the example shown, each branch circuit is supplied with power. Each branch circuit load is controlled with an individual switch that controls current to the load. In the example shown, the power supply is moved from a vertical position to a horizontal position. Each branch circuit is connected to the power supply. Each branch circuit is shown in a horizontal position. Notice that the black wire from the power source connects to all of the load devices. This is referred to as a common connection. Notice also that each branch circuit load is controlled by switching only one wire, the red one. Circuit diagrams drawn with horizontal components is called a ladder diagram since it resembles a ladder. The vertical drawing connections are called rails or power rails. The horizontal drawing connections between the rails are called rungs. A ladder diagram is a drawing that shows both power connections and the branch circuits connected to the power rails. A ladder diagram shows the device or devices controlling the power to each load connect to the rails. Each load in the ladder diagram requires a connection to both of the power rails. Typically, ladder diagrams place the control devices to the left of the load. The right power rail typically has no control devices connected to the load. Ladder diagrams are used for circuit design, construction, and interpretation. The load in each branch circuit require power from the source. The operating voltage of the load is typically assumed to be the same as the voltage source. Therefore, many ladder diagrams do not show the operating voltage, but only the main power connection points. These power connection points are typically labeled L1 and L2. Even though a circuit could be controlled with a switching device on the right side of the load, industry standards typically place all circuit control components on the left side of the load. Circuit loads should not be designed or wired in series. Circuit loads wired in series do not receive the necessary voltage and may not operate correctly. Ladder diagrams are an electrical representation of circuit control. Every component has a diagram symbol representing the component. It is important to recognize ladder symbols to understand circuit operation and design. Ladder diagrams use symbols to represent components. Ladder diagrams do not use physical drawings of components but the symbol that represents the component. In the example, the switch and the lamp are replaced with the correct symbols for a switch and a lamp. Also in the example, the push button and the lamp are replaced with the correct symbols for a push button and a lamp. A few ladder symbols are shown. Notice that each symbol represents a specific circuit operation. Interpreting ladder diagrams is very important. A ladder diagram consists of two parts, the load, and the devices that control the load. As shown here, no control devices are connected between L2 and the load component. Circuit design typically place all load controlling devices between L1 and the load. Ladder diagram design, interpretation and troubleshooting centers around the circuit path of L1. The circuit path of a load may include components in series, parallel, or a combination of both. It is important to understand the current path of the control circuit to the load. It is also important to recognize symbol references for the components controlling the load. Computer programs are available that simulate ladder circuitry. These programs may be very helpful in the design and operation of ladder diagram circuits. The programs typically offer a wide range of ladder symbol libraries and allow for circuit simulation. A ladder diagram, also referred to as ladder logic, is an electrical drawing that uses symbols to represent the components and loads of electrical circuits. The diagram is drawn in such a way as to resemble a ladder. Ladder diagrams provide for a thorough understanding of a circuit, and is an essential tool for circuit design, and a helpful tool in troubleshooting.